Aboard the U.S. carriers, few of the pilots had combat experience. The U.S. Wildcat fighters were outclassed by the Japanese Zeros. The American Devastator torpedo bombers were obsolete, and their torpedoes were outdated. Some pilots called themselves the Coffin Squadron. At 7 a.m., the U.S. carriers launched their attack aircraft. To meet them, the agile Zeros rose like flies from the decks of the 4 Japanese carriers. As the U.S. dive bombers flew towards their targets at 20,000 feet, down below, at sea level, the Zeros wiped out all but 4 of the Devastators, which had failed to secure a single hit. But the Japanese, distracted by the sea level attack and lacking radar, did not sight the American dive bombers until too late. The first armor-piercing bomb struck at 10:26 a.m., the last at 10:30 a.m. Those 4 minutes were the turning point of the entire war in the Pacific. All 4 Japanese carriers were destroyed. It was June 4th, 1942. As the American pilots returned to the carriers, they did not know they had won one of America's greatest naval victories. The Japanese had lost 2,500 men, 234 aircraft, and 4 carriers. They would never recover from this loss. The American losses were 307 men and 1 carrier, but the U.S. flag still flew over Midway. Admiral Nimitz said that the Battle of Midway could not have been won without the code breakers. The U.S. Chief of Staff wrote, "If it hadn't been for the cryptanalysts, we would almost certainly have been 3,000 miles out of place." After Midway, the Japanese were always fighting a defensive war. Meanwhile, 1942 was also a critical year in the Atlantic, and there codebreakers also played a vital role. Prime Minister Winston Churchill believed that German U-boats were the greatest threat faced by Britain. If the stream of supplies flowing from America to Britain in thousands of convoys had been broken, then Britain could not have continued to hold off Hitler. The greatest threat to the convoys lay in what was called the 1,000-mile Black Gap, the area in mid-Atlantic where there was no air cover possible from west or east. The U-boats could close in on the convoys under cover of darkness and deliver their attacks. In 1942, the U-boats were gaining the upper hand. They had sunk several million tons of Allied shipping, and the eastern seaboard of North America had become a killing ground. Admiral Karl Dönitz, the commander of the U-boat fleet, used his submarines in groups called wolf packs. This strategy depended on Enigma messages. On the wall of his command bunker, Dönitz had a huge checkered map of the North Atlantic. Day and night, signals enciphered on Enigma machines flashed to and from the U-boats as the Admiral placed his submarines like chess pieces precisely across the tracks of the Allied convoys. They sent hundreds of ships and their vital cargoes to the bottom. Naval officers in London worked around the clock trying to steer the convoys around the wolf packs, but there was very little intelligence. The code breakers had to break the German Navy Enigma. At a country house near London called Bletchley Park, British and U.S. code breakers toiled in a group of huts to decipher the orders of the German High Command. Their daily task was to solve the 6-letter key or indicator that showed the German rotor settings for that day. One of them was Arthur Levinson of New York.
By concentrating on one key and seeing the traffic from that operator day after day, you got to know some of his likes and dislikes, and particularly in the selection of indicators, which was left to the individual. And certain individuals tended in certain directions. Some engaged in obscenities, which were helpful. Some were fans of American movie stars. And in one case, the outside indicator was Tom, and we thought maybe the inside Tom. It turned out it was Tom Mix, who fortunately had a 6-letter name.
Two Cambridge mathematicians, the eccentric genius Alan Turing, often regarded as the father of the modern computer, and Gordon Welshman had devised a machine to test the possible settings of the rotors. The machine was essentially a stack of 12 three-rotor Enigma wheels which tested possible combinations. Eventually, the British had 60 of these machines running 24 hours a day. Without them, the breaking of Enigma would have been impossible. There were thousands of intercepts a day. They already had great success with the Luftwaffe and Army codes, in part because the German operators selected their own keys. But in the German Navy, the keys were rigidly laid down on a monthly sheet. The U-boats continued to devastate the convoys. Then a young Bletchley codebreaker, Harry Hensley, suggested a plan. A naval task force from the base at Scapa Flow in Scotland would race north to ambush a German weather ship in hope of capturing the monthly key sheet. It worked. Another break came when a U-boat was depth charged to the surface, and a raiding party led by 20-year-old David Baum got on board.
The 12-volt secondary lighting was on. The main lights, of course, had all been broken by all the depth charging, but there was a dim light. You could see enough. And it was very quiet, no generators running like you have in a ship all the time, no hum, deathly silence, just the hissing, a nasty hissing noise coming out of the batteries, presumably, gas escaping, and then the rolling to and fro to Atlantic swell, the plop of the sea. By far, of course, the most important thing was the Enigma machine. And there it was, screwed to the cable alongside the wireless set. And of course we didn't know what it was. We knew it had something to do with decoding, because it was a typewriter, looked like a typewriter. And my telegraphist, we always carry a telegraphist in an armed boarding party. He had a screwdriver, he unscrewed it, we passed it up. And of course the miracle was it wasn't dropped overboard.
Bletchley Park could now read the U-boat signals, and the vital shipping saved during this period kept Britain fighting. Then in February 1943, Dönitz introduced a new 4-rotor Enigma to be used only by the U-boats. Once again, Allied codebreakers were blacked out, and the U-boats again wrought havoc among the ships. In Britain, the decoding machines could not be built fast enough. But in America, more than 200 of them were constructed. They were operated 24 hours a day by special teams of waves at Naval Headquarters on Nebraska Avenue in Washington. One wave was teenager Ronnie Hulick.
I joined a small contingent of waves that was sent to Dayton, Ohio, to the National Cash Register Company. In Dayton, we were assigned to a building and sort of a laboratory. We sat at a table with these small wheels. We were given a soldering iron and many little wires of different colors and a graph to follow. And we soldered the little yellow wire here, the little green wire over here. And this went on for an 8-hour shift. When we left the building, another shift came in and proceeded to wire the rotor wheels. One day we came on duty and were told that we were going back to Washington, D.C. And when we returned to Washington, we were assigned to barracks near the Naval Communications Annex. It was on Nebraska and Massachusetts Avenue in Washington. The first day on duty, we were ushered into the chapel. And a naval officer got up in the pulpit. And I remember thinking, isn't this lovely? They're welcoming us here with a prayer, a little benediction. And this big fellow proceeded to tell us that the work we were about to do